back, everyone. Today we're going to continue with the same chapter, whole numbers. But in this chapter we're going to learn a new subtopic. Subtopic's name is properties of whole numbers. So let's start the lesson. What is the property of whole numbers? The whole numbers are the part of the number system in which it includes all the positive integers from 0 to infinity, but do not include fractional or decimal parts. The properties of whole numbers based on arithmetic operations, which are addition, subtraction, multiplication, and division. The two whole numbers, if added or multiplied, will give a whole number itself. But when we subtract two whole numbers, we might not always get a whole number. It can also be an integer. Also, division of two whole numbers results in getting a fraction in some cases. So, we are going to learn about now the closure property of whole numbers. In addition, when we add two whole numbers, the sum will always be a whole number. For example, x plus y is equal to z. So, we can change that to 7 plus 8 is equal to 50. In these, the answer and both the added are all whole numbers. In multiplication, when we multiply two whole numbers, the result will always be a whole number. For example, x into y is equal to z. We can change that by 7 into 8, which is equal to 56. In this, the multiplicand and multiplier and the product are all whole numbers. In subtraction or division, when we subtract or divide two whole numbers, the result will not always be a whole number. For example, in subtraction, x minus y is equal to z. We can replace that by 7 minus 8, which is equal to minus 1. And in division, for example, will be x divided by y, which is equal to z. We can replace that by 7 divided by 8, which is equal to 7 by 8. In both subtraction and division, the numbers are the product or the sum are not a whole number. So that means only closure property only works in addition and multiplication, not in subtraction or division. So now let us learn commutative property of whole numbers. In addition, the sum of two whole numbers will not change even if the orders of the number are changed. For example, x plus y is equal to y plus x. We can replace that by 7 plus 8, which is equal to 15. And if we even change the order, 8 plus 7 is also equal to 15. In multiplication, the product of two whole numbers will not change even if the order of the numbers are changed. For example, x into y is equal to y into x. Or we can replace that by 7 into 8, which is equal to 56. And if we change the order, it will be 8 into 7, which is equal to also 56. In subtraction or division, the difference or quotient of two whole numbers will change if the order of the numbers are changed. In subtraction, for example, x minus y is not equal to y minus x. We can replace that by 7 minus 8, which is equal to minus 1. But if we change the order, it will become 8 minus 7, which is equal to 1. For example, in division, x divided by y is not equal to y divided by x. So if we replace that by 7 divided by 8, which is equal to 7 by 8, and if we change the order, it will be 8 divided by 7, which is equal to 8 by 7. And we already know fractions, so 8 by 7 is an improper fraction. So to make it a mixed fraction, it will become 1 by 7. So this also means that commutative property only works in addition and multiplication, not in subtraction or division. Now we will learn about the associative property of whole numbers. In addition, when three or more whole numbers are added, the sum will not change even if the groups are changed. For example, x plus y plus z is equal to x plus y plus z is equal to x plus z plus y. So we can replace it by 7 plus 8 plus 9 is equal to 15 plus 9, which is equal to 24. And then 7 plus 9 plus 8 is equal to 16 plus 8, which is also equal to 24. And 7 plus 8 plus 9 is equal to 7 plus 17, which is also equal to 24. In multiplication, when three or more whole numbers are multiplied, the product will not change if the groups are changed. So for example, x into y into z is equal to x into y plus into z is equal to x into z into y. We can replace that by 7 into 8 into y, which is equal to 56 into 9, which is equal to 404. And 7 into 9 into 8, which is equal to 63 into 8, which is equal to 404 also. And 7 into 8 into 9, which is equal to 7 into 72, is also equal to 404. So that means in addition and multiplication, all the answer, sum and the product will be the same. It will not change. The difference between commutative and associative property is that in commutative property this works for only two numbers, whereas for associative property it works for three or more whole numbers. So in subtraction or division, when three or more whole numbers are subtracted or divided, the sum will change when the groups are changed. So for example, in subtraction, x minus y into minus z is not equal to x minus y into minus z is not equal to x minus z minus y. So for example, in subtraction, 7 minus 8 minus 9 is equal to minus 10, and 7 minus 8 minus 9 is equal to 8, and 7 minus 9 minus 8 is equal to 16. So the sum will change if the order of the numbers are changed in both subtraction or division. So that also means that associative property works only in addition and multiplication, not in subtraction or division. Now we will get a summary of closure, commutative and associative property. This means that closure, commutative and associative property both work in addition. All three work in addition. All three do not work in subtraction. All three work in multiplication, and all three do not work in division. Now let us learn about the distributive property of multiplication. Distribute means to give each member of the group, like a newspaper man delivers newspaper to each house of the community. Distributive property of multiplication over addition. This property is used when we multiply a whole number by a sum of two whole numbers. We first must multiply each added and then add the products. So for example, 5 into 8 plus 4, which is equal to 5 into 8 plus 5 into 4, and 5 into 8 is equal to 40, and 5 into 4 is equal to 20. So 40 plus 20 is equal to 60. Distributive property of multiplication over subtraction. This property is used when we multiply a number by a difference of two whole numbers. We first multiply subtrahend and minuend with the outside number, then subtract the products. For example, 5 into minus 6 minus 3, which is equal to 5 into 6 minus 5 into 3. 5 into 6 is equal to 30, 5 into 3 is equal to 50. So 30 minus 50 is equal to 50. Distributive property of multiplication over versus order of operation. Distributive property is used to make a calculation easy. So now we will try to solve two questions in order of operations, which is equal to 8 into 50 plus 3. So which is equal to 8 into 50. We don't know the tables of 53. So we will not be able to do this multiplication. It's not that much easy, isn't it? 3 into 400 plus 23, which is equal to 304. 3 into 420. We don't know the multiplication table of 423. So this isn't so easy, isn't it? But now, if we try to solve these questions in distributive property, we will be able to get the answers very easily. Let's try to solve these now. 8 into 50 plus 3, which is equal to 8 into 50, which is equal to plus 8 into 3. And we don't need to know the multiplication table of 50 to know this, because we can just take 8 into 5, which is equal to 40, and after getting 40, add a 0 at the end. And if you all know the multiplication table of both 8 and 3, so 8 into 3 is equal to 24. That is equal to 400 plus 24, which is equal to 424. Isn't that easy? Now let's try to solve our next question, which is 3 into 400 plus 23. 3 into 4, which is equal to 300 into 400 plus 3 into 23. For this, we don't need to know the multiplication table of 400. So we can just take 3 into 4, which is equal to 12, as we all know, and then add 2 zeros at the end, which is equal to 1200. And we also don't need to know the multiplication table of 23 for this. We can just do 3 into 2, which is equal to 6, and then we'll add a 0 at the end, which is equal to 60. And 3 into 3 is equal to 9. So 60 plus 9 is equal to 69. That'll make our answer to 1200 plus 69. And if we do the addition, it will become 1269. Isn't it easy now? Now we will learn about the property of 0. The subtractive property of 0. If 0 is subtracted to a whole number, then the value will be same of the whole number. It will not change. So for example, x minus 0 is equal to x only. We can replace x by 7. We'll get 7 minus 0, which is equal to 7 itself. Multiplicative property of 0. If 0 is multiplied to any whole number, the value of that whole number will become 0. So for example, x into 0 is equal to 0, and 0 into x is also equal to 0. So if we replace x by 7, we get 7 into 0, which is equal to 0, and 0 into 7, which is also equal to 0. Now we will learn about the property of identity. Additive identity. If 0 is added to any whole number, the value of the whole number will be the same. It will not change at all. So, for example, x plus 0 is equal to x, and 0 plus x is also equal to x. So, if we replace x by 7, we get 7 plus 0, which is equal to 7, and 0 plus 7, which is also equal to 7. The multiplicative identity. If 1 is multiplied to any whole number, the value of the whole number will be same. It will not change at all. So for example, x into 1 is equal to x, and 1 into x is also equal to x. So if we change x by 7, we get 7 into 1, which is equal to 7, and 1 into 7, which is equal to 7. So, what did we learn today? We learned what is whole number and its properties, the closure property of whole numbers, commutative property of whole numbers, associative property of whole numbers, difference between commutative property of whole numbers and associative property of whole numbers, the distributive property of whole numbers, the distributive property of multiplication, which is the order of operations, the property of zero, and the identity property. So if you guys like the video, please like, share, subscribe, and hit on the notification bell to get more notifications when I upload more videos. Thank you and have a nice day. Bye.